Hello and welcome to Chapter 5. In this lesson, we are going to learn about annual worth analysis. And this chapter would be much easier if we are already familiar with the present worth analysis, which I have covered in a previous video. This is because the methods and principles of annual worth analysis are almost similar to the present worth analysis. So please watch that video before proceeding with this lesson. In this lesson, we are going to learn how to compare alternatives using an annual worth basis. First, a brief recap. An alternative that is being evaluated using present worth analysis or annual worth analysis would typically have these cash flows. Firstly, there would be a first cost of purchasing that asset, and that is cash flow at T0 here. And at the end of the lifetime of the asset, there could be a salvage value or resale value of that asset, and this is shown by the cash flow labeled as here. Additionally, throughout the lifetime of the asset, there could be a series of periodic and uniform cash flows, which could be annual operating cost or annual maintenance cost of that asset. And that series of cash flows is shown here, which is labeled A, which stands for annuity. So what are the applications of annual worth analysis? Annual worth analysis is used to compare and evaluate alternatives based on annual worth. So annual worth analysis can be used to determine the annual costs of operating and maintaining an asset over its lifetime. Annual worth is also used in capital recovery analysis, and I will show an example of a simple capital recovery analysis in the next slide. In an annual worth analysis, all cash flows are converted into annual worth value, which then becomes the basis for comparison. This is an example of using annual worth in a capital recovery analysis. In this example, you invest 5,000 ringgit on a vending machine, and this is shown as a first cost in your cash flow diagram here. You plan to operate the vending machine for 4 years, and at the end of the year 4, you plan to resell your vending machine. So that's your salvage value right here. So a question that can be asked is, how much must the vending machine generate in annual revenue over 4 years in order for you to recover your initial investment at 10% rate of return? In order to answer that question, the first cost and the salvage value of the asset must be converted into annual worth value, and that annual worth value is actually the annual revenue that the vending machine must generate in order to recover your capital at the required rate of return of 10%. There is an example of capital recovery analysis later on in this lesson, and I hope that example will further clarify these points. Annual worth analysis is also used to compare alternatives in order to determine which alternative is more profitable. In this example, you have two different vending machines with two different cash flows. By using annual worth analysis, all these cash flows are converted into annual worth values for a given rate of return, which then becomes the basis for comparison and determining which vendor is more profitable or economical for that given rate of returns. Annual worth analysis is preferred over the present worth analysis due to these advantages. Annual worth analysis can be applied over one life cycle only, unlike present worth analysis, which sometimes must be applied over multiple life cycles. The same annual worth amount can also be assumed for future cycles, which can be changed with inflation rate. annual worth is also known by these other names, which include AE, which stands for annual equivalent, EAC, which stands for equivalent annual cost, and EUAC, which stands for equivalent uniform annual cost. This example demonstrates how annual worth analysis can be applied for one life cycle only, instead of over multiple life cycles. In this example, we have an asset with a first cost of $20,000 and an annual operating cost of $8,000 and a lifetime of 3 years. We are asked to find the annual worth for one life cycle and 2 life cycles at the stated MAR. So the cash flow diagram for the asset looks like this. You have a first cost of $20,000 at T0 and an annual operating cost of $8,000 per year for 3 years, and these cash flows are for the first life cycle only because one life cycle lasts for 3 years. In the second life cycle, the asset is repurchased, so that's why you see another $20,000 spent in year 3, and then you have the annual operating cost of $8,000 per year, which extends from year 4 until year 6. So that's another 3 years for the second life cycle. Now let's find the annual worth for one life cycle, which is rather straightforward. You just need to convert the first cost of $20,000 into annual worth for over 3 years, and then you just need to add the annual operating cost of $8,000 per year. And since the annual operating cost is already an annual worth, so there's no conversion that needs to be done. You just plug in the value of $8,000 per year. Then if you plug in the numbers into the formula, you will find that the annual worth of one life cycle is equal to $17,793 per year. Next, let's find the annual worth for 2 life cycles. So the calculation of annual worth of 2 life cycles is shown here. In the first term, the first cost of the asset is converted into an annual worth over 6 years because we are now considering 2 life cycles. In the second term here, the second purchase of the asset, which occurs in year 3, is first converted into a present worth value at T0. So that's why you see P given F conversion factor here for over 3 years, which is then converted into annual worth value over 6 years. In the third term, the annual operating cost of $8,000 per year is added to the equation. Then if you do the maths and plug in the numbers into the equation, you will find that the annual worth of 2 life cycles of this asset is also $17,793 per year. As a conclusion, the annual worth of one life cycle is the same for all life cycles or multiple life cycles, and this is the reason annual worth analysis is preferred over present worth analysis, because annual worth analysis needs to be applied over one life cycle only. So therefore, it is easier to be performed and more straightforward. Now let's see how annual worth is used in a capital recovery analysis. Capital recovery is the annual amount that an asset must generate every year in order to recover the first cost at a stated rate of return over its lifetime. So as an example, take a look at this cash flow diagram of an asset here. So at year 0, you have the first cost of purchasing or installing that asset, and at the end of the lifetime of the asset, there is a resale value or salvage value of that asset. So when we calculate capital recovery, what we are trying to find is the annual amount in revenue that the asset must generate every year throughout its lifetime in order to recover this first cost at a stated rate of return. Salvage value is also considered when calculating capital recovery, and this is shown in this formula here. CR, or capital recovery, of that asset consists of two parts. The first part is the first cost of that asset, which is converted into annual worth value. So that's why you see the A given P conversion factor here. And the second part of the equation is the salvage value, or the resale value of that asset, which is also converted into annual worth value. And because the resale value of that asset is the future worth of that asset in the future at the end of the lifetime of the asset, so that's why you see the A given F conversion here. So what's happening in this term here is that the future worth of that asset, F, is converted into annual worth value at a stated rate of return over its lifetime N. One thing to note is that the sign of the terms in this equation here. The first term is a negative sign because the first cost, cash flow, is a cost. So that's why it's a negative. The second term here, the salvage value, has a positive sign because what's happening when you resell an asset is that you receive cash. So that's a positive cash flow. So that's why there is a positive sign before the second term in the equation here. Now let's try this example of finding capital recovery and annual worth for this project. This project has a first cost of $13 million, a salvage value of $500,000, and a lifetime of 8 years. We want to determine the capital recovery amount of this project at 12% interest rate. So let me explain what's happening here. In the first term, the first cost of the project is converted into annual worth amount. So that's why you see the A given P conversion here. In the second term, the salvage value of the project is converted into annual worth amount using the A given F conversion. So we find that the capital recovery amount of this project is equal to negative $2.576 million per year. So the interpretation of this capital recovery amount is important. So the interpretation is that the project must earn an annual revenue of $2.576 million per year for 8 years in order to recover the initial investment and make 12% rate of return. Now let's extend the same example by considering that the same project also has an annual operating cost of $0.9 million per year, and we want to find what is the annual worth of this project. So the annual worth of this project is equal to the capital recovery amount, which we have calculated, plus the annual operating cost of the project. And the calculation is rather straightforward because both the capital recovery amount and the annual operating cost are already annual worth values. So we don't need to do any conversion on the figures because what we are trying to find is the annual worth of the project. So we find that the annual worth of this project is equal to negative $3.476 million per year. So the interpretation of this figure is that this project must earn an annual revenue of at least $3.476 million per year for 8 years to recover its initial investment and the annual operating cost and make 12% rate of return. Now let's look at the steps and procedures to apply annual worth analysis to single and multiple alternatives. Now for single alternative, the annual worth of that alternative is calculated at the stated MAR over its expected life. And if the annual worth of that alternative is bigger than 0, then that alternative is economically justified. Conversely, if the annual worth of that alternative is less than 0, then that project is economically not justified. So therefore, it must be rejected. For multiple alternatives, the annual worth of each alternative is calculated at the stated MAR over the respective life of each alternative. And it is not necessary to apply LCM method or least common multiple method if the alternatives have different lifetimes. After the annual worth of each alternative is calculated, the alternative with the numerically largest or most positive annual worth value is selected. So as you can see, the steps to apply annual worth analysis are almost similar to the steps to apply present worth analysis that we learned in the previous chapter. But the difference is that in annual worth analysis, you do not need to apply LCM method if the alternatives that you want to compare have different length of operating lifetimes. Therefore, annual worth analysis is more straightforward and easier to perform compared to present worth analysis. Now let's try this example to apply annual worth analysis to compare two different alternatives. We have two different equipments, equipment X and equipment Y, and each equipment has its own first cost, annual cost, salvage value, and operating lifetime. We want to apply the annual worth analysis to determine which of these equipments is more economical. So what we are going to do is we are going to convert these cash flows into annual worth values, and then we are going to compare the annual worth values for both alternatives, and then we will make our decision. So let's first find the annual worth value of equipment X. So let me explain what's happening here. In the first term, the first cost of equipment X is converted into annual worth value. In the second term, the salvage value of equipment X is converted into annual worth value. And the third term is the annual operating cost of equipment X. And since the annual operating cost is already an annual worth value, so you don't need to do any conversion, you can just plug in the number. So if you apply the relevant formulas to convert these two terms, you will find that the annual worth of equipment X is equal to negative $36,077 per year. So what this figure is telling us is that owning and operating equipment X will cost $36,000 per year. Now let's proceed to calculate the annual worth value for equipment Y. So by comparing the annual worth values of both alternatives, so we find that the annual worth value of equipment Y is more positive than the annual worth value of equipment X. So therefore, we select equipment Y. Another way of interpreting this result is that by choosing equipment Y, we only need to spend about $32,000 per year. But if we choose equipment X, the cost of operating and maintaining the equipment is more expensive because it will cost us $36,000 per year. Now here is another example of applying annual worth analysis to compare two different alternatives. Now I'm showing you the solutions for this example so that you could try and see if you can get the same answers. Alright, so we have arrived at the end of this lesson. Thank you for your attention, and these are the problems for chapter 5 that you can try. Thank you.